Hi, it's Robin. If you've watched my videos for a while, you probably know I love the 10 print program. Here's one example of it. Just a single line program that, when run, generates interesting patterns that are reminiscent of a maze viewed diagonally. Well, I guess it doesn't matter which way it's viewed, but it is like a diagonal maze. So I was interested to learn that earlier this year, a new variation on this program called 10 print orthogonal 32 bytes was released March 14th, 2021 by Logiker, who you might remember made the really cool directory art that I showed a couple years ago. He made it so that when you list the disk directory, an animated wrestling match occurs, and it was for a wrestling game release. So anyway, it was quite interesting. Okay, so I've got that program here, and we'll run it. And so you see it's a maze, but instead of being diagonal, it's, I suppose, orthogonal. And it's actually really interesting patterns that occur. You know, I'm really partial to that original diagonal version of it, but the more I look at this, I realize what cool patterns there are in here and what very interesting looking mazes, sometimes with little rooms and those little doorways and so on. Again, a neat little program. And as you might have guessed from the name of the program, it's just a 32-byte program which was entered in a 32-byte intro competition. And there are these kind of competitions all around the world, or sometimes virtually, where people try to make a game or a demo or an intro in a limited number of bytes. And I think 32 bytes might be the smallest one I've ever heard of. So yeah, we're looking at the listing here. It is just a single line of code. So again, it's just a print command, but instead of just printing one of two characters, the slashes here and here on keys N and M, it's actually got 6 different characters that are put in this constant string, and then the midstring function is called, which chooses one character, and the random number is generated, multiplied by 6, so you get a number from 1 to 6, which is the position in this constant string. So basically just one of these 6 characters is chosen at random and printed, and then goto just causes it to loop again. And he is doing this trick, which I think I covered in an earlier basic optimization episode. If you leave off the line number, goto actually assumes line 0, and as long as you do have a line 0, this trick works. So looking at this program, I really couldn't see any way of improving it, shrinking, optimizing it, except one way. The program could be made a tiny bit faster by replacing this constant 0 with a dot or period, full stop. Commodore Basic Parser does parse slightly quicker. When it sees just a period, it takes a shortcut and evaluates that as a 0. So I thought I'd give that a try. Here we go. What? So all I did there, you saw it, was attempt to edit that single line of basic code, and this happened. The computer seems to have crashed. Okay, I have recovered, and now our program's gone when I even try to list it. So this is the other interesting thing about this program, just besides, it's a cute program, it makes interesting patterns, but a bit of clever trickery was required to shrink that program down to 32 bytes. Okay, so to try and look into what's going on, the first thing we'll try doing is loading that program with a (8), and if we list it, there's no program there at all. So if we try loading it with (8), (1), it actually hangs. And this is the discovery I made when I tried to run this program on real hardware. It freezes, while on an emulator, it runs fine. So actually I have to wonder, when this was entered in the competition, did that competition just run it on an emulator? And when Logiker wrote this, did he test it on real hardware? But that's a clue. If something runs on emulator but not on real hardware, that is almost always a memory initialization issue, and that's a clue as to what the trick is that he's doing here. So I'm going to reset, and I'm going to look in memory here at 800, and we can see here that the rest of memory is filled mostly with this AA and 55 pattern and occasional variations on it here. And this first part is that program that we loaded. So what I'm getting at here is that most emulators initialize RAM to all zeros, while real hardware with real RAM comes up in a so-called random state, but really it usually ends up initializing, at least on this model of C64 with the pattern AA55. That RAM initialization really can't be relied on real hardware. And different models of C64, different RAM types, end up with different numbers here at initialization. The vital thing is that you're probably not going to end up with RAM filled with zeros on real hardware, while on an emulator, you probably are. And I think Logiker was relying on those zeros when shrinking this program down to 32 bytes. There was an assumption made that RAM would be filled with zeros. On a hunch, I'm just going to add a few more zeros here. So I'm just initializing the end of the program RAM with zeros. And we're just going to try loading 10 print, 8, 1 again. And that time it loaded fine. So we'll go back into the monitor. Oh, I hope this is making sense. And we can look at the program here and see there's the 0 at the beginning of the program. Every Commodore Basic program needs that 0 at the beginning. Then there's a 16-bit pointer to the next line of the program, and that's at 0820, which is down here. And when it's just a one-line program or whatever, when you get to the last line of the program, it gets terminated with 20 bytes. What Logiker had done to shrink this to 32 bytes was chop those 0 bytes off the end of the file, and it worked okay in the emulator. Okay, so zeroing out those 2 extra bytes enables the program to load. And I think what's happening is that if those are not 0, the program loads, and then the basic interpreter tries to relink, that is, set those pointers to the next basic line automatically, and it just wanders off and crashes because it's not finding those 0 bytes that it expects to be there. Okay, but I think we still haven't fixed the problem. I was trying to edit this program, and if I hit dot, okay, it still is crashing. Okay, so there's another problem here, another workaround. Okay, so we still have a bit of fixing to do here, a bit of work to do to get this to work. The next thing is, why is it crashing when I try to edit the program? Well, there's some pointers that BASIC uses that are really important. And they're located here in 0 page, starting at 2B. The first one is a 16-bit pointer. As always, it's low byte then high byte. So to read it, you got to swap them around. So 0801 is the beginning of basic memory. That's where the interpreter looks. Okay, so there, I'll just list it there. So there is the start of the program. And then the next 2 bytes, 0820, they're the end of the basic program plus 1, or also known as the start of variables. And you can see this pointer here is pointing to 0820. Well, where is 0820? It's right here. Basically, this is the end of the basic line, and then here is the first 0 byte and the second 0 byte that indicate the end of the program. Now, you see what the problem is. It's saying that the end of the program is at 0820. That's right here. Well, that's not the end of the program. That is near the end of the program. It's pointing at those 2 0 bytes that indicate the end of the program. So really, the pointer should be to this location, which really is the start of variables and the end of the basic program plus 1. This is set by the load routine. After it loads the program into RAM, it then increments by just 1 more byte and sets this pointer to the end of the program plus 1, or the start of the variables. Again, because of the shortcut that Logiker has taken, this optimization arguably, or this hack, this is off by those same 2 bytes. So all that to say is that really we should set the start of the variable space to 2 bytes more, 0822. So now it's pointing here. And if we exit and list, now I should be able to edit this. Let's see. There we go. Good. Yep, and it's actually done it, and the program is still runnable. I should have said earlier, we're doing this is educational. This is a look behind the scenes, both at the optimizations Logiker did and how BASIC works. Now, if you could tell, that's slightly faster. I think it works out to like a couple percent faster. Okay, but we're not done with the optimizations yet. I think there's one more here, and it has to do with how we have to load the file, 8, 1. When I load, how if you load 10print, 8 to load it to the start of memory, it doesn't work. So if we load it with the modder, it'll show the load address, and that is 0802. One more than usual, which has the net effect of making the program 1 byte smaller. So I think really he got his program down to 35 bytes and then chopped off 2 at the end and 1 at the beginning. Okay, so if we do this, so we're doing direct disk access here, even though I'm using my micro IEC, the flashcard solution, this is inside a D64 file, so I should be able to use some of these direct sector access commands. So that's U1 is to read a single block, and that's at track 18, sector 1. This is where the disk directory lives, and it loads those 256 bytes by default into memory at C1000. So that's what we're examining here. And we can see here's the 10print program, and it starts at track 11, sector 0. That's 11 hex. So let's load that in, 11, 0, and look at memory. Okay, and here is the file on disk. In a Commodore DOS block, the first 2 bytes are reserved as a pointer to the track here and sector of the next block in the file. But when you're in the last block of the file, in the case of this single block program, track pointer of 0 means that this is the last block, and the second byte, instead of pointing to the sector, tells us what the last valid byte is in this block. So that says 21 hex, and that points to here. So this is the last valid byte in this block. And then the next 2 bytes are the load address. So there's high byte of 08 and low byte of 02. And again, that would normally be 0801. That's being bumped up to 0802 to reduce the file size by 1 byte. And this is the last bit of the cheat here, is that 99 token is the print. Normally between the load address here and the first instruction, there are usually 4 bytes. 2 bytes, which are a 16-bit pointer to the next line, to its location in memory. And then there's 2 bytes that are a 16-bit line number. But you can see this 00, that's the line number. This 08 is only half of the pointer to the next line. So really, what's happened is by adding 1 byte to the load address, we're skipping over the first byte of the line link address and relying on the Commodore Basic Interpreter to recalculate that line as it scans the program. So that's the one other optimization. I think that one does work even on the real hardware, that there isn't a problem with that. It can be, if it's not 0, that's okay. It can be some other byte, and the C64 will fix that automatically. And yeah, as we were saying, the last valid byte is at offset 21. That's the 0 that indicates the end of the line. And then there really should be these 2 bytes included as 0 as well. But that's the problem from loading. In fact, another way of fixing this program, we could actually just bump this up, I believe, to 23. And it will now include all 3 zeros in a row. Here at offset 20, 21, 22, and 23. But the file is no longer only 32 bytes long. It's actually 34 bytes and no longer qualifies for that competition. So we can actually write that back into memory with U2. I think this will work. Okay. I've reset. Let's see if that works. So I'm going to try loading 10 print, comma 8, comma 1. And it worked. I list it. I'm going to modify it. And that worked fine too. And now we can run it. Who would have thought it could be so complicated to explain a little 32-byte program thoroughly enough? I hope I did it thoroughly enough. So, well done to Logiker for those various tricks. Although, if it doesn't run on any real hardware, I gotta give that a partial thumbs down. But, you know, if you knew that the competition was using emulators, and that's what they specified, as long as it runs on that emulator. On the flip side, if you're at a competition, you know, they insist on just using an emulator because it's easier to hook up for a wild competition from all the different platforms. And then you've got some trick that only runs on real hardware, you could actually get disqualified because they can't get your demo to run. So that was fun to figure out. Hey, thank you to my patrons for support, and a special big thanks to my friend and patron Jay, who has made the scroller that you're about to see for the end credits. He programmed this himself in assembly language. We went back and forth on it quite a bit as he figured out some bugs. Hey, if you're interested in becoming a patron, there's a link in the video description. And if you want to try downloading this little program, there's a link to the C64 scene database in the video description, and you can check out other things that Logiker has made. All right, thanks for watching, and we'll talk to you next time.
Then